So how are we going to take the integral of 1 over x minus 1 with respect to x? Well, of course, we can just try to think as a u-sub, where u is just a denominator. In that case, our dx will just be the same as du. Therefore, if we take the integral of 1 over u after having the u-sub with respect to u, of course we're going to get ln of u. And with the absolute value, where what is u? In this case, it would just be our denominator, x minus 1. And don't forget, we have the plus c, and we are done. Okay, now we have an integral of 1 over, instead of x minus 1, we have x squared minus 1, and of course with respect to x itself. So how are we supposed to do it? This time we're going to use partial fraction to break the rational function 1 over x squared minus 1 into two parts. Namely, we have the factor of x squared minus 1 here, which will be x minus 1, and then x plus 1. Then if we try to solve for this rational function that is equivalent to the original function that we have, we actually will get our coefficients be 1/2 and -1/2. So we can in fact write this as negative or minus 1/2 for the second part. And now we actually have two rational functions where the denominator is just degree 1 polynomial. So what can we do? Well, now we can use the law that we can break it into two parts since there's a minus sign here, so that we actually get 1/2 of the integral of 1 over x minus 1 dx minus 1/2 integral of 1 over x plus 1 dx. And we can just take the integral of each part. So we actually get 1/2 of ln of the denominator minus the 1/2 of ln of this denominator here. And of course, we can actually combine these two together to get 1/2 of ln of absolute value x minus 1 over x plus 1 plus c, and we are done. Okay, this time we actually have x to the third power minus 1 instead of x minus 1 or x squared minus 1 in our denominator. Then what should we do? Of course, first step, we still want to break it as using partial fraction by rewriting x cubed minus 1 into x minus 1 and x squared plus x plus 1 as the two fractions that we should have. And of course, don't forget we have dx at the end. Now, what are we going to do? Well, we can actually use the covering method to figure out the first part. Since our denominator is x minus 1, we're going to set x equals 1 and then plug it into the parts that is remaining, which is in fact x squared plus x plus 1 to get 3 in the denominator. So in fact, our coefficient of the first term will become 1 over 3. Similarly, if we try to do it the same way, we'll actually get negative 1/3 times x plus 2. So in this case, we now have two fractions, and we can just rewrite it as an integral of each part. And we can also factor the 1/3 coefficients on each term to get 1/3 times the integral of the first part, which is again ln of the denominator x minus 1. Then we have factor out the negative. We have the integral of x over 2 all over x squared plus x plus 1 dx. Now what should we do next? Of course, we cannot just simply rewrite as the ln yet, because what we actually have here is we don't have the x term in the denominator. And how can we rewrite it? Well, we can actually try to break it a little bit further, which is we can try to get this as x plus 1 over 2 squared plus 3 over 4 is the denominator, such that on top we can rewrite as 1 x plus 1 over 2 plus 3 over 2. And now we can just break this second part here into two fractions again and get the integral of the denominator over this here, where we can just make a use of as u over u plus 3 over 4. Am I correct? No. We have a 2 here, so don't forget the square. And then we are going to change the dx into du as we replace the x plus 1/2 as by u. We take the derivative on both sides, we get dx over is equal to du. Then we have the other part, which is the constant negative 3 over 2 of the integral of the denominator here. So we get the first part will become ln by substituting t equals the denominator, such that when we take the derivative on both sides, we get dt is equal to 2u times du. So if we take the integral, we now actually get 1/2 of ln of t, which is the denominator here. And we can see that the denominator is always positive. And now we need to figure out the last part, which actually has the form of the derivative of arctangent. Therefore, we can actually rewrite as the arctangent of this, which is x plus 1 over 2, the thing inside the square, divided by the square root of the remaining part, which is square root of 3 over 4. And then don't forget, we have to undo the chain rule by multiplying the inverse of the square roots of 3 over 4. So, in fact, we're going to multiply with the square root of 4 over 3. Now we're going to collect all the like terms and then try to cancel out some stuff. Let's see what we have. We have 1/3 times the first term, which is ln of x minus 1. And then minus the second term here, which has to be multiplied with 1/3 and give us 1 over 6 times the ln of u squared plus 3 over 4. And what is u squared again? Well, again, u is just x plus 1 over 2. So if we substitute back in and multiply out, expand it, and then add the 3 over 4, we actually will get x squared plus x plus 1. And last but not least, we have the last thing. And let's see, we have 1/3 and the third will be cancelled out. Then we have a 2 here and the square root of 4 that will be cancelled out. So what we actually end up with is 1 over radical 3 times arctangent of this thing here. And as we try to kind of rationalize it, we have 2x plus 1 all over the radical 3. And last but not least, don't forget, we need to put our favorite letter, plus c, and we are. Now we are going to move on to the integral of 1 over x to the 4th power minus 1 dx. And again, what's the first thing that we can do? Of course, we are going to try to break it using partial fractions. So in that case, we know that if we factor out the denominator, we will get x minus 1, x plus 1, and then x squared plus 1. These three terms. And of course, we have dx at the end, and then we have the integral sign in the front. And if we try to see what we should do, we actually can guess that our coefficients of the first term is 1 over 4. And in fact, everything will just be 1 over 4 times some other constants, just like what we see in the last part. So we can actually get the 1 over 4 outside. And then if we do it that way, it's the same as multiplying the numerator by 4. And in that situation, if we try to plug it into the other terms, for x minus 1, we will actually get the coefficients to be 1. And then for x plus 1, we actually get the coefficients to be negative 1. And last, it will give us minus 2. So we now can just take the integral of each part to get the integral of the whole thing would be 1 over 4 times ln of x minus 1 minus ln of x plus 1 minus, now we see that here the denominator is x squared plus 1. Again, it is no longer ln, but our integral would be arctangent of the denominator, which is just x, over the square root of 1, which is x. And don't forget, we have to multiply with the numerator that we actually started off at. And we have the plus c here to actually give us the result. And we can try to combine the like terms to get 1 over 4 ln of x minus 1 over x plus 1 times 1 over 4 times 2 to give us 1/2 of arctangent of x plus the constant c. And so finally, we actually have the most difficult level, the integral of 1 over x to the 5th power minus 1 dx. So this time I'm going to skip all the explanation. You can just watch me fast forward and then see how the steps go and then read the final result.